1, 3, ordering real numbers. So example 1, compare the square root of 3 plus 5. Is it greater than or less than or equal to 3 plus the square root of 5? Well, first, let's find out what the square root of 3 is. So if we take the square root of 3, I got 1.73. And if I add 1.73 plus 5, I get about 6.73. So the left side is 6.73, about, approximating. Now let's do the square root of 5. So the square root of 5 is 2 and about 24 hundredths. And if we add 3 to that, we get 5 and about 24 hundredths. So if we're looking to see which one's bigger, 6 is bigger than 5. So we're looking at the square root of 3 plus 5 is the larger. Alright. Let's take a look at the next one. Okay. The square root of 2 is going to be plus 4. Oh, wait. So we have the square root of 2 plus 4 will get me 5 and 41 hundredths. And if we do the square root of 4, well, the square root of 4, that's easy, that's 2, but if you just want to double check, you got 2. 2 plus 2 is 4. 5 is bigger than 4, so our inequality is going to face this way, to the left. Alright, the square root of 12 is going to be 3 and 46 hundredths plus 6 is going to be 9 and 46 hundredths. Alright, the square root of 6 plus 12 will get me 14 and 45 hundredths. Okay, 14 is larger than 9, so the inequality is going to face towards the right. Alright, let's go to the next one. Alright, example 2. We want to arrange the square root of 22, pi plus 1, and 4.5 from least to greatest. Alright, so if we have the square root of 22, square root of 22 is about 4 and 69 hundredths. Pi plus 1, so if I type in pi plus 1, I get about 4 and 14 hundredths. And 4.5 would be about 4.5. Alright, so if you look here, the one that's going to be the smallest is the pi plus 1, which is closer to 4 and 2/10. Then the next is going to be 4.5 because 4.5 is smaller than 4 and 69 hundredths, so it'll be here. And then lastly, square root of 22 would be last. And we want to write it in its original format again. Alright, so let's do number 5 and number 6. Okay, the square root of 5 is going to be about 2 and 24 hundredths. Two and 5/10 is just the 2 and 5/10. And then lastly, the square root of 3 is going to be about 1 and 73 hundredths. Alright, so if we're arranging these from least to greatest, the square root of 3 is going to be the smallest. 1 is the smallest whole number out of these. Now these both have the whole number 2, but this is 2/10 is smaller than 5/10. So we have the square root of 5 second. And lastly, 2 and 5/10. Alright, so now we're going to plot this on the number line. So 1 and 73 hundredths is going to be somewhere right about here. And we'll say the square root of 3. And then we have the square root of 5 will be about here. And then lastly, 2 and 5/10. So that's basically what it looks like on a number line. Alright, number 6, we have pi squared. Pi squared. Oops. Let's clear that. I don't know what I typed. So pi and squared. I got about 9 and 87 hundredths. Okay, then we have the whole number 10, and then the square root of 75, which is about 8 and 66 hundredths. Okay, this one's easy. Just looking at whole numbers alone, 8 is smaller than 9 and 10. So we're going to say square root of 75, then pi squared, and then lastly 10. So when we plot this, we'll have square root of 75, and then we'll have pi squared, and lastly 10. Okay. Flip it over to the back side. Alright, example 3. 4 people have found the distance in kilometers across a canyon using different methods. Their results are given in the table. Order the distances from greatest to least. Okay, this time you got to be careful because it is greatest to least. So we want to do the square root of 28 first. So for the square root of 28, I get about 5 and 29 hundredths. Alright, 23 fourths. I get 5 and 75 hundredths. 5 and 5/10, or well, it's a repeater, so it's like 5.555 ... forever and ever. And then 5.5, you should have that memorized as 5.5. If you need to, you can line up the dot and compare them. So you have 5 and 29 hundredths, you have 5 and 75 hundredths, 5 and 55 forever and ever, and 5.5. Okay, remember, I want the greatest. one first. So all the whole numbers are the same, so then you got to compare in the tens place. 2, 7, 5, or 5. Well, the 7 is going to be first. Okay, then after that you have a tie between the 5s. But in the 100 spot, this is a repeating 5 and this is a 0. So this is going to be second, third, and fourth. Okay, so we need to rewrite it in the proper way. So 5 and 29 hundredths is actually written as, 5 and 75 hundredths is written as 23 fourths. Then second is 5.5 with a line over it. Then third is 5.5. And lastly is 5 and 29 hundredths, which is the square root of 28. Okay, and here it is graphed on a number line. Okay, the last one. 4 people have found the distances in miles across a crater using different methods. The results are given below. So if we do 10 thirds, I get 3 with a repeating 3. 3 and 45 hundredths, that's just 3.45, 45, 45. 3.5 you should have memorized as 3 and 5 tenths. And then lastly, square root of 10. We get about 3 and 16 hundredths. Alright, we want to order the distances from greatest to least. So if you want to use the same strategy we did up here, you can have 3 with a repeater 3. You have 3 and 45 hundredths with the repeater 45. You have 3 and 5 tenths. And then you have 3 and 16 hundredths. Alright, we're looking for the greatest, so the first step is to compare the whole numbers. They're all 3. Go to the tenth spot. You have 3, 4, 5, or 1. 5 is larger, so this will come first. Okay, then 4 is second, third, 3 is third, and lastly 1 is fourth. Remember, we want to write it in its original format. So 3 and 5 tenths was actually written as 3.5. Okay, after 3.5 was 3 and 45 hundredths. Alright, and then we had Jonathan, which was 10 thirds. And lastly was LaShonda with the square root of 10.